Hi, my name is Mike White, and I am a co-CEO at FTL Labs. The Navy has asked our company to find a way to improve the resolution of small marine radars for submarine navigation. We have developed a modular and scalable system that improves conventional submarine radars and fits within the defined small pressure-proof pods, but can also be applied to improve larger, more modern radar systems. FTL Labs is an 11-year-old small business that develops hardware and software solutions for a wide variety of challenging problems for the DoD that are then licensed or directly commercialized. We have extensive experience in winning SBIRs and turning them into real products. Products created by FTL engineers have undergone rigorous mil-spec testing and became standard equipment on military platforms. Our 5,000 square foot lab and office space is located in Amherst, Massachusetts, surrounded by several universities and colleges that provide us access to needed fabrication, test facilities, and expertise. Our engineers have multiple commercialization success stories, including the auto-grade fuel sensor, which was installed on Navy aircraft carriers, and licensing custom sensor solutions to Parker Hannifin. Modern submarine navigation systems use small aperture magnetron X-band radars in a 20-inch by 8-inch pressure-proof cylindrical pod mounted on a penetrating mast. These small volumes come at the expense of radar angular resolution, yet IEC regulations require strict radar detection and resolution of small, distant, and closely spaced contacts, such as navigation buoys, small vessels, and channel markers. The Navy seeks new COTS-based architectures, apertures, and processing approaches to improve radar performance while observing current volume constraints on Virginia and Columbia-class submarines. FTL is using a novel approach to modify magnetron-based radars to make this inherently incoherent system coherent on receive, providing access to emerging coherent radar processing approaches for increased resolution and Doppler shift extraction of targets. These modifications to magnetron-based radars allow the Navy to get better performance out of the radars they have existing on submarines and other vessels. Our modular and scalable software ingests coherent radar data from either a modified magnetron-based radar or a modern solid-state radar and applies cutting-edge digital signal processing algorithms to achieve high-resolution radar imaging. There are two key innovations of the SharpScan system. The first is the novel hardware modifications to a magnetron-based radar that allows the capturing of coherent IQ radar returns. The second is the modular and radar interchangeable software that applies emerging radar signal processing to achieve the highest resolution in both range and bearing, providing a flexible, simple to implement, and easy to upgrade radar system. As I am sure many of you are aware of the SBIR process, the SharpScan technology development started in Phase 1 and is now in its second year of a 3-year Phase 2 contract. We have already developed a TRL-6 prototype where we have tested a functional prototype of our system on board a Navy Sea vessel. By the end of Year 2 of this Phase 2 contract, we plan to be at TRL-7, having tested a system that meets all form, fit, and function requirements on board a Navy at Sea vessel. Our goal is to have a system ready for transition onto submarine platforms by the end of Year 3 of this Phase 2 contract. There are many benefits to our modular SharpScan radar design. The first is that our hardware modifications can easily be applied to submarine navigation radars that are already in the fleet to provide at least double the resolution in resolving targets, even in congested spaces like harbors. The second benefit is that these modifications allow current systems to provide essential target information to the warfighter that is not currently available. One example is target velocity. Further, SharpScan's modular software architecture allows raw data from the radar to be saved and recalled for further analysis on targets of interest, and allows incremental software upgrades to implement new cutting-edge algorithms as they are developed. SharpScan has been developed in collaboration with L3Harris, General Dynamics Electric Boat, and Raymarine to ensure the product is ready for transition to the fleet after the Phase 2. Additionally, there are many planned ship testing exercises with the Navy over the next 2 years to help provide a smooth technology transition to submarine navigation radars. This technology is also modular and scalable so that it can easily be adapted to many marine platforms beyond just submarine navigation radars. I want to thank you for listening to this presentation. I have enjoyed sharing our SharpScan technology with you. FTL Labs is a small business with the ability to provide innovative, commercializable solutions for some of the DoD's toughest problems. We would be happy to talk with you further about any opportunities to use our SharpScan technology to enhance your radar system.